Okay, good morning. So today we're going to cover the first lecture, and in this lecture we mainly discuss the relational database system, and we basically give a very quick review of what is a relational database system, and also what are the data models, and also some database language like the data definition language, data manipulation language, and also we discuss the main components of the database engine. Also, we're going to discuss some database architectures and also users, and finally the history of the database systems. Okay, the first thing. So what is a database system? So basically a database system we consider contains two parts, the data itself and then a collection of the programs used to support the database access, database data manipulating, and so on. So usually we call this second part as database management system. It's also called DBMS. Okay. So in this case, a modern database is considered a very complex system. So it's handled complex data, but also the DBMS is also complex. And it is able to perform a lot of functionalities to support the database operations and also to maintain the data in the database system be valid and accurate. So then the data stored in the database nowadays are considered very valuable because usually we use data to support an organization's operation. Okay, so data may contain a lot of information that can support the organization to make a good decision. And also data are very large, unfortunately, or for good or for bad. So because the advancement in the database system and in the information technologies allows us to, to collect data as much as we want. Okay. And another thing we have to know about the database system is that a database system is considered as a multi-user environment. So basically, you build a database to support kind of a lot of operations that needed by the company and also needed by the people to perform their job. Okay, then you have to think about that since at any moment the data in the database can be accessed by different users or by different application programs, then the concurrency control is very important. So it means that if the two different programs or users trying to access a same piece of data, one is for reading, the other one is for writing. So how to kind of coordinate those operations so that after both user or both applications finish their job, then they won't get the right result, okay, or the right information about data. And also database touch all aspects of our lives. So whether we are aware of it or we are not aware of it. So basically pretty much, so for example, if you go shopping, either online or you go to physical store, then a lot of database involved in those actions, right? If you go to online shopping, then the online merchants, they have to have their own database. They may have database to store their inventory. They also have database to store their customer information. They also have database they use database to store their kind of order information, shipping information. If you go to the physical store, like a Walmart or the Kroger, then there's so many different databases you'll be involved in your shopping experiences. For example, when you pick up a merchant and if you scan, then those scanning operation will update the Kroger's inventory, right? Inventory database. And also when you make the payment, depending on if you pay cash, that's fine. If you, for example, if you're the loyalty member of the Kroger, you scan your member card or you type your member card information, then that will be related to the members database. Okay, when you pay, what's happened? If you pay by your bank card or credit card, then your bank database will be involved to report what has been spent, right? So how much has been spent on which date. And if you use your cell phone, the same thing, pay for payment. not only the card associated to your cell phone view, their database will be updated, and also as long as you carry your cell phone provider, service provider will also have database to track your move. Okay, not only your move and the data you use, and the calls you make, and the calls you receive, and the text message, for example, you receive or you send, and also the internet, the web browsers you browse, maybe the social media accounts you visit. So those information will be all recorded by different database systems. So here it shows several database application examples. For example, for the enterprise, they may use database for what? To store their sales information, including their customers, products, and purchases. They also use for accounting purpose to record payments, receipts, and costs. And also they also use database for human resources, right? To record information about their employees, their salaries, and payroll taxes. And also manufacturer can use database to, for example, to handle their inventory orders, supply chains, or production. And also for the banking and the financial industry, they also use database to save the customer information, customer account information, their loan information. And also for the credit card transactions, they also need to handle that part. And then they also, I think a lot of the bank and financial institutions, they offer some financial products. They also need to have database to store those products. And then for the university, so I think that's very obvious. I think right now you probably read this class online, right? You pay for your tuition online, and also you check your grades, you check your schedule online. So all those information will be stored in the database. And for the airlines, I think airlines basically, I don't know, have you ever encountered the problem that, so for the airline, they have to maintain a database to record their flights and their booking information, okay? So for example, during the hot season, like the holiday season, the summer break, maybe, I mean, a lot of people want to travel. So it is possible that a lot of people try to reserve the same flight roughly at the same time. I think a lot of airlines, they provide services that you can pick the seat, right? So it's possible that for some popular seats, it's possible that at the same time, there may be more than one people trying to select that seat. So who's going to get the seat? Do you know? So if two people trying to select or reserve the same seat, so who is going to get that seat? Do you know?
First is whoever booked the seat first.
Yeah, whoever what?
First come, first serve.
First come, first. I mean, so first come. What does first come means? Means they click the button to reserve the seat, or
have done the payment for the seat.
Very good. So whoever pay that seat, they will go. So before anybody pay for that seat is open to anyone. So it's possible that maybe 10 people trying to, right? But whoever paid the first will get the seat. Okay, so I do have that experience because I try to reserve a seat and then I'm kind of off track. When I come back, the seat is no longer available. Okay. And also for the telecommunication companies, I think that's pretty obvious. So they have to use database to report all your data usage, your costs, and also text message you sent, and also your locations, okay? So that they can provide the best services or maybe charge you the best for the services you use. And there are some other database systems like web-based services. So it's kind of used for the online retailers and for the online advertisements. So basically, I think those online retailers and online advertisements basically will keep track of what websites you browse, and they probably can figure out your personality, your interest, your hobbies, so they can send the advertisement targeted to you, okay? So those also they have to use those database to collect the customers or users information. So they're now more like a document databases and navigation systems. So they all have to use database to support their complex functionalities, okay? So majority of them might be using the relational database, but nowadays we also have non-relational database like the MongoDB graph database and so on, GIS. So these all there are all kinds of different database systems that nowadays that we have used. But I think in this class, since we have those two recommended textbooks, so we're going to mainly focus on the relational database, okay? But if we have time, I also want to introduce some non-relational database. I think I'm going to focus on the MongoDB, a document kind of database. Okay, so the key properties of the database systems. So once again, I think in our discussion in the first lecture, we'll mainly focus on the relational database system, okay? So for the relational database system, atomicity is one of the key features every database must enforce. So what's the atomicity? Atomicity basically means that a collection of transactions either all executed successfully or they will be aborted. So no, they will not produce any impact on the data. So why this is very important? Because it is possible that there's some system failure, there may be the like power outage. So during the execution of a transaction, a sequence of the operations, suddenly the system breaks down, okay? So then after you restart the database system, what do you expect? You don't want those half-executed transactions will leave the track in your database. Then because that will always result in unstable or inconsistent state of the data. For example, you think about you try to deposit money to your account. Maybe we do it online, okay? During the deposit process, suddenly maybe your internet, you're off the internet, or maybe the banker's database kind of for some reason crashed. So after the database recovered, what do you expect? So you only expect two possibilities. One possibility means that the deposit transaction is not executed, so you're still able to redeposit, okay? Or the deposit will be done and reflect on your account, but nothing in between. So that's basically what the relational database needs to enforce. So it's called atomicity. So this basically means that given a sequence of transactions, either they all be executed successfully or none of them, is executed. So that's kind of what the database needs to retain, this property. Then the concurrent access, I think in the introduction, I did mention that concurrent access should be controlled, okay? Because we have multiple users, multiple applications, they may submit the operations at the same time, and those operations might be interleaved during execution, okay? And if they happen to access the same piece of data item in the database, then you have to control their access so that the final outcome for each user or each application will be correct. And also the final outcome is similar to that every user or every application, their transaction is executed in the sequence. So when one is done, then the next one will be started, okay? So that's kind of the overall outcome. So you want to, no matter how the operations are interlinked, then their results is similar, is exactly same as those transactions are executed in sequence. So there's no interleaved transactions. Okay, so then the security problem. So we have multiple users, multiple programs. I think each user should have different access privilege. So that's why security is very important. We need to control the access to make sure that the user or applications can only access the data, they are allowed to. Then for the data abstraction, so basically we know that database system contains two parts, the data itself and then the database management system, which is a collection of the programs to handle all kind of operations of the database, like access, read access, write access, update access, and delete access, and so on. So then a major purpose of database system is to provide users with the abstract view of the data. That means that you want to hide all the implementation details from users. So user only see a very abstract view of the of the database. So that's the data abstraction purpose, okay? Then data model is considered one type of data abstraction. So data model, in this class, we're going to discuss two data model, the relational data model and entity relationship data model, okay? So these two data model, pretty much, they are doing the same thing. So they kind of only represent the abstract view of the data. So user can, from those abstract views, user can understand what kind of data stored in the database, what are their relationship. But regarding where the data is stored, how data is stored, we don't know. Okay, they don't need to know. Okay. So then, for the examples of data models, include relational data model, the entity relationship data model. So these are two popular data models considered as high-level design of the database. We need to use those two data models to represent the data. And also there's some other data models like object-based data model or object-oriented data model or object relational data model. So those models basically utilize object-oriented concept, okay, to organize data. Then we have semi-structured data model like XML. And also we have two very old data models called network data model and hierarchical data model. I think those two are seldomly used nowadays. And this shows the data organization of a relational data model. So in a relational data model, we organize data into tables. Okay, this table has a table name called the relation name, and also has column header, we call the attributes. Okay, so this, and then each record, according to the relational data model, we call tuple. Okay, so this shows that if we organize data in a relational data using relational data model, then data will be represented as a collection of tables. Okay, so that's our typical relational data database looks like. And this shows the sample database. Since we organize data into tables, and a relational database will contain a collection of tables. Okay, so that's called relational database. And then for the relational database, we do have data definition language. So what is data definition language? So it's kind of used to define the database schema and the data in the database. So here we have one example that create table, this kind of SQL statement, command name, then department, then decode name and chairperson. So in this case, we define a table, kind of a table, and also we define the structure of the table. So this table's name is called department, and then it has 3 columns or 3 attributes, right? Okay, so one thing I want you to be aware of that in the relational data model, there's one key requirement. So basically, this key requirement basically says that every table must have, or every relation must have a primary key. A primary key given a table can be either a single attribute or a set of attributes whose combined values is unique for every record in that table. Okay, so why do we need the primary key? So if we have the primary key, means that if we given a table, if that table has a primary key, then we can have a set of attributes or either single attribute. We can use that value to uniquely retrieve one tuple or one record at a time. Okay, so it means that no 2 records can have the same primary key value. So the primary key value can be serving as the ID, okay, for each record in the table. So that's very important thing you need to know that. So if you create a relational database, then every table must have a primary key, okay? So once we submit this query, so this is called data definition language, then a schema of the table will be created, and also this table's information will be stored in a data dictionary. So sometimes we also call the data dictionary as data catalog. Okay, so data dictionary stores the metadata. So metadata is the data about data. So in the data dictionary, we know like how many attributes in a table. what's the table's name. For each attribute, what are their names, and also their format, their data type and the storage format. Okay, so data type and storage format together give us a clear idea how to store that kind of piece of information about that attribute. Okay, so we may have char string, but even the data type is char string, but the format maybe we use like 15 characters to store that char string or 100 characters, that's a storage format. Okay. And also the constraints. So in the relational database, it defines several constraints. So why constraints are important? Constraints will help us to maintain the accuracy, consistency of the data. Okay, so we do have constraints between the foreign key and the reference key. We also have constraints about the primary key. We also constraints about the domain constraint, domain of each attribute. Okay, and also we have some kind of for each application, it may have its own constraint, like the not null constraint. For example, if I want to collect information about each of my class, I want to report student's name. Okay, then in my data collection process, the student name can never be null. So that's can be the constraint for that particular application. Okay. And also data dictionary contains authorization. So authorization pretty much determine what a user can access or application program can access. Okay, so they're kind of the access privilege. Okay, then for the data manipulation language. So this is language for accessing and updating the data stored in the database. And also DML stands also called query language. So maybe you guys have already know the SQL programming. So SQL stands for structured query language. So SQL consider both data definition language and data manipulation language because we can use SQL to create tables, and also we can use SQL to update the contents, to insert records, right? Update or delete data from the table. So that's why SQL is considered both data definition language and the data manipulation language. Okay. So for the data manipulation language, is considered as a collection of the programming languages that used to do the data updates on the database. So the updates can be the operations to create new records, read existing record, update the existing record, and delete the record. So those are the 4 operations that's used to change the data in the database. So this shows example of the SQL query. Okay, so SQL query is considered as non-procedure. Basically means that the query takes either one table or multiple tables as input, and then the results will be put into a single table. Okay, so that's what you're looking for. So in the standard SQL query, usually it's made up of like at least, these 3 statements. Select from where, okay? So select statement list all the columns names that whose information you want to be included in the result. Then the from clause list all the tables that are needed to get the information you want. And the where clause just simply specify the conditions so that only the records satisfies those conditions their information will be included in the result, okay? And also, if we only use SQL query, you can tell that SQL query, these kind of functionalities are limited. You have to follow its grammar in order to let the database know what to do, right? So then most of the time, if you want to integrate more complex functionalities into your program, then you may want to use SQL, embedded SQL in a high-level programming language, like using JavaScript, Java, Python, and so on, PHP, so that the high-level programming language can integrate some complex logics, if else then loop, and so on, or even procedures for data analysis, pre-analysis, or post-analysis after the query has been executed. And also, application programs generally, so when we talk about application programs, those the programs implemented in some high-level programming language. So they can also access database through one of the 2 options. One is that it's called a language extension to allow embedded SQL to the high-level programming language. I think language extension pretty much supported by all high-level programming language. The other one is that you use application program interface to access, to submit query to the database. Then for the database design, so I think in this class we also will review the database design. So usually the database design contains two parts. The first part called the logical design. So logical design, by logic means that we don't consider any implementation details. We just sketch what the data will be stored in the database. What are the relationships? What are the constraints? Okay. So logical design can be, I think, usually when we talk about logical design, we usually consider building relational data model. So in a relational data model, we organize data, a set of attributes into tables. Then different users may have different organization. So finally, we need to find a way to organize attributes into tables so that that's considered as a good design. Okay. And also in our logical design, we also have two considerations. One is that we have to consider the business needs. So what are the attributes, or what kind of data business need to store in the database? Second one, we also need to consider the computer science requirements, means that how we can organize data so that organize data into the different schemas so that they represent a good design, a good organization of the data. Then regarding to the physical design, that's one way to store the data into the database. Then for the physical design, some consideration may be, are we going to store the data as separate tables, or maybe sometimes we have to do the denormalization. We have to combine several tables together. But usually this is not encouraged unless you have strong kind of arguments that we need that, and that's really for the performance purpose. Okay, you can also store some views, and also most important things that you want to speed up the data access, right? So that's why you want to build the index on the attributes of certain tables in order to speed up the query execution. But you also have to sacrifice the storage space and system resources, and also CPU time when you build up the index. So that's why how to build up index and what attributes you want to build index is also needs a careful consideration. Okay, now the database engine. So database engine basically can consider database management system. So this engine usually contains multiple components. Each handles different functionalities of the database system. So overall, there are three major components of the database engine. One's called storage manager, and then the other's the query processor or query processing engine. The last one is the transaction management engine or transaction management component. Okay, so for the storage manager, so this is the kind of module that provides the interface between the low-level data stored in the database and the application programs and the queries submitted to the system. So basically, storage manager need to understand what kind of data need to be processed and where to locate them in order to retrieve the information. Okay. And so the storage manager is responsible for the following major two tasks. The first one is what? To interact with the OS file manager. So at the end, the database has to have some system to host system. This can be the Linux system, it can be the Windows server, and so on. So then the database data will finally be stored as files in the host system. So that's why the storage manager of the database needs to interact with the OS, the operating system file manager. And also the storage manager need to provide efficient storing, retrieving, and updating the data. So using the index or maybe using the buffer. But we do have the buffer manager, okay? And also storage manager components include some subcomponents. The most important one will be the authorization and integrity manager. So authorization and integrity manager, this actually handle two different functionality. Authorization manager basically will identify users and based on their role, and then assign the access privilege to the users. Okay. Then the authorization manager will determine whether a user is able to access the data or not, and what kind of data a user can access. The integrity manager is mainly used to enforce the integrity constraints of the data. So by enforce those constraints, then it can guarantee that regardless how data is updated over time, the data stored in database will be always valid and consistent. Okay, hopefully also accurate. Sometimes valid doesn't mean that it's accurate. Then for the transaction manager, so the transaction manager basically is kind of a component that handles the transactions. Okay, so it ensures that all the transactions are either successfully executed or none of them is executed. Okay, after the finish. And also it manages the concurrency control to make sure that even several operations from different applications are interleaved, but we have to do the concurrency control to make sure that the result of each transaction will be correct. Okay, and then for the file manager, so file manager basically pretty much handles the how to efficiently access files. Okay, read data and read data, and also how to kind of minimize the disk rate. So the disk I/O pretty much will affect the overall system performance. Okay. Then the buffer. So buffer manager basically buffer is kind of memory space used to store the data retrieved from the hard disk. Okay. So buffer manager also is important. So usually a buffer manager will implement efficient, we call it caching strategy, so that it can also minimize the disk I/O, but also provide quick access to the data. Okay, so it's basically will determine, because buffer is much smaller than the file system, physical file system. So the buffer needs to determine which part of the file need to be loaded beforehand to the buffer in order to handle the data access request. Okay, so if it's this kind of scheduling, if it has a smart scheduling, it will always prefetch the data into the buffer before those will be needed in the query. But if they prefetch the wrong data, that's not only involve more disk I/Os, but also kind of delay the query execution. So that's why buffer manager is also very important to kind of to speed up or to improve the performance, query performance. Okay. So for the storage manager, it also have to handle different types of data, sequential data, hash data, and so on. And also the storage manager also have to store the data dictionary. So data dictionary is a special kind of a repository of data. So basically, every database must have data dictionary. Why? Without data dictionary, then the database does not know the semantics of data, does not know the constraint of data, does not understand the data format and so on. So that's why data dictionary is very important. And also storage manager also will implement indexes for the quick data access. Then the query processor usually contains three parts. The DDL interpreter. So DDL interpreter just interprets DDL statements and then store their appropriate or corresponding information into the data dictionary. Whenever you create a table using DDL, then this table information will be stored in the data dictionary. Okay, also. Then DML, data manipulation language compiler. So this basically will translate the DML statements in a query and then into called an evaluation plan. So this evaluation plan will be later used to execute part. Okay, so this evaluation plan will consist some low-level instructions that the evaluation plan will understand. And also DML compiler will perform optimization. So optimization is very important. So because if you think about the SQL query, it only provides a table name and a column name and then some kind of conditions. It does not tell the database how to retrieve the data, okay, and how to combine the data together. So there's so many things consideration. If you think about if you want to implement, for example, the query needs like 2 tables, and it's only need 1 column from each table, so 2 columns at the end. So either you want to load the 2 tables, the entire table into the main memory for the data processing, or you only want to load the required columns into the main memory. Okay, so there's so many different considerations you can think about in order to what to optimize query. But optimize query means that you want to load as little as possible data, but able to complete the data computation, okay, to retrieve information that need by the query. Then finally, the query evaluation engine will perform the queries, okay? So this shows the query processing, the whole process. So given the query, it will first go through this parser and translator to understand the query, to understand which tables will be needed and which columns will be needed. And then the query will be translated into the relational algebra expression. And this expression can be understood by the execution plan. Then the optimizer will come in too. So depending on the statistics about data. So I think this data statistic will be also stored in the data dictionary. Okay. Then based on the physical data statistics, then optimizers will determine which execution plan will have a minimum cost. By minimum cost means that will has utilized the minimum memory space and has minimum disk panels, okay? And then it will basically the evaluation engine will perform the query and then you generate the result. Okay, so this kind of query processing process. No. Then the transaction management. So I think a transaction consider a collection of the database operations. So the basic database operation is only 2, read and write. Okay, you read things and write. Write can also consider, okay, delete things, wipe out things. Okay. So a transaction management component will ensure that no matter what the database status, if a transaction has been executed, then it will leave the database in the right state. By state, we mean the data of the current moment. Okay, so if during the execution of the transaction, if something happens, the transaction will be aborted. That means that those partially executed statements, their kind of effect on the database will be wiped out, roll over. So it means that they will not leave any trace in the database for those partially executed transactions. Then for the concurrence control manager, I think that's the same thing. So it's handle the interleaved actions to make sure that every transaction after finish, it will end up with the correct result. Okay, no incorrect result produced. As to the database architecture, so we have centralized database. So that means that we have 1 or 2 to a few cores and shared memory. Okay, everything will be done in a centralized fashion. Then client server. So we have client machine and a server. So client basically the computer or application that submits the query or application to the server, and the server will perform execution of the query. Okay. Then we have the parallel databases. So that means that we have multiple databases they are run in parallel. We can handle the operations in a parallel fashion. And then we have distributed database. That means the data may be distributed across different platforms over the big network. Okay, so that's kind of the different database architecture. And then for the database users, so we have, I don't know if you're able to read it. This is called naive users. So those users, they do not know any, maybe they have very little database background. So in order to access the data into the database, you usually use some application programs. Okay, so through the application interface, they are able to, for example, query the data or access data in the database. Then we have application programmer who is basically builds application programs for the database access. We also have sophisticated users, may like you guys, so we're going to use some query languages to retrieve data from the database. We also have the DBA, who's used to administer and control the resources and the users of the database. So I think this shows kind of very nice kind of a flow of how each user will interact with the database. So for the naive users, through the application interface, they're going to submit some commands. Usually this is more like a forms and a web-based form or some other kind of forms. So those application programs will generate object codes, can compile and generate object codes. And then those object codes will be spit into the query evaluation engine for the execution of the query, okay? For the application programmer, they're going to use application programs, and then through the compiler and the linker, they're going to generate the application programs is going to be generated as application object codes, and then you interact with query evaluation engine for the performance. Okay. Then for the sophisticated users, they use query tools like SQL, kind of SQL client, and then they submit SQL queries, and those queries basically will be kind of input to the compiler, DML compiler, and then submitted to the query evaluation engine. And those compilers will also work with optimization engine and the query authorization engine to make sure that the query is able to execute it. So if the user trying to access a table is not allowed to, then those in authorization manager will deny the access. Okay, so that's pretty much the users. Then for the application architectures, I think we have two-tier architecture, client server, or we have three-tier. I think that's more popular. So we have client machine act at the front end, and in the middle we have application server, and then at the bottom we have the database server. So client machine interact with application server, and then application server will interact with the database server. So through this architecture, then the client is able to submit the programs or applications through the front end, then to access the database. I think that's pretty much similar to what we just discussed. Okay. Then regarding to the history, I think in the 1950s, my history is very bad, so that's why I'm trying to explain. So basically in 1950 and 1960, so at that time, I mean, the database, I think, still rely on the file system. So in 1950 and 60s, files usually stored in the magnetic tapes, okay? And use punch cards for output. And then in the late 1960s and 1970s, first hard disk allowed to direct access to data. So, and the hard disk replaced the magnetic tapes to store the data. But still, I think data are organized in the files. Okay, there's no efficient or sophisticated database management system to support a variety of the applications. Then the network and hierarchical data model is widely used. Then the Dr. Ted Cott and kind of published a seminal paper in 1972. It's about relational data model. So this paper has attracted wide interest because of its simplicity and also the foundation, the mathematical theory foundation behind that model. Then after that, some research prototypes of the relational database have been kind of developed, and also because of his contribution, Dr. Ted Cott won the very prestigious ACM Turing Award. Then in the 1980s, we have seen a lot of commercial relational database systems like Oracle and also IBM. And also the parallel and distributed database system have been developed and used. And also there's some kind of efforts to try to develop the object-oriented database systems. But I think these efforts didn't last very long, okay? Then the 1990s, people start to realize that we have collect a lot of data in the database. There's some values buried in the database systems. So that's why the large decision support and data mining applications have been taken off. Okay, so we have data warehouses to hold the data, historical data, maybe of the last 10 or 20 years. Okay, then people trying to do the data mining on those data warehouse data, trying to dig the patterns, the useful patterns for the. And in the 1920s, it's come with big data storage systems like Google Bigtable. And the Google Bigtable is considered fully managed called a wide column and the key value NoSQL database. So do you know what is NoSQL? So NoSQL is not no, not SQL, it's called not only SQL. Means that besides relational database, we also need some other database types of database that can accommodate the new emerging data requirements and application requirements. And then in the 1910s, the SQL reloaded, so means that SQL can kind of revamped so that it comes to the front end, to the MapReduce system. And also we have seen the rise of the massively parallel database systems and the multi-core and the main memory database system. So I think they all used to handle big data application. Okay, and that's pretty much it for today's lecture. Any questions? No? Okay, so I think the next one, I believe, I want to give a brief discussion on the assessment. So what do you think for the assessment? I think we don't have much time left. So what do you think about assessment? You think that you think it's harder, or is it okay? Or do you have any questions regarding to the assessment questions? Let me see. Okay, so we only have one student missing. So do you want me to discuss assessment or not? Yes or no?
Yes.
Yes? Okay, good. So let me see. So let me, I think for the assessment, there are two types of questions. One type is about your understanding of the relational data model, the key, the super key, right? And then you have about 3 questions about SQL programming. Do you guys have any experience in SQL programming? No? Yes? No? Okay, so yeah, that's kind of because of rhythm. So you don't worry if you didn't know SQL programming. I just want to know the general backgrounds of your database background in the class, so that I'm able to either put more emphasis on the SQL programming or not. Okay. So for the let me show you. Let's start. Okay, so because this is the random generated context map, so I won't be able to repeat the question you have, but you have pretty much similar questions. So let me first to do the key questions. So for example, in this question, it's asking a relation schema. So it's a table. Factor is table name, factor ID, office telephone number, name, rank, and department. So there are about 5 attributes. And assume that each factor has a unique factor ID and a unique office telephone number. So what does that mean? It means that either one of them can be the primary key. Because they're unique means that every factory has a unique FID and also has a unique office telephone number, okay? So it means that we have two keys, okay? By key, we mean that either a single attribute or set of attributes whose value is unique for every record in that table. Okay, so in this case, unique FID. So FID is a key, and office telephone number is also a key. Okay, so key also satisfy the minimum added function. Means that key must be minimal. By minimal means that it does not have redundant attributes. By redundant attributes means that we can remove those attributes, then the remaining attributes still satisfy the uniqueness. Okay, so in this case, both FID and office telephone number are the keys. Okay, so it's asking which of the following can be a key of factory. So the right answer should be the FID is one and office telephone number is another one. So the name in this case is not, because we may have faculty have the same names, although it's not very often, but it's possible, right? The rank, the same thing. So we may have multiple faculty with the same rank at assistant professor level, at the associate professor level, or at the full professor level. So rank is not unique for everyone, so it's not. Then office telephone number, the name. This is not considered as a key. Why? Because name is redundant. Means that without name, office telephone number is still the key. You understand? So key must be minimal, cannot have any redundant attributes. Okay? So that's why office telephone number name is not the right answer. The D is the right answer. So D, office telephone number, is unique and it's minimal. Okay? By minimum does not mean that it only has one attribute. It means that it does not have redundant attribute. Okay? Then the none above is not. Then FID is one. Okay? Then the department is not, because department is not unique for every faculty. Okay? So the right answer should be these two. Okay? Then let's go to another one, the super key. So what's a super key? The differences between the super key and the key, that super key can contain redundant attributes. So super key must contain a key. Okay? So if a super key only contains the key but nothing else, then super key is also a key. You understand me? But since super key is more relaxing, means that super key can contain some actual attributes beside a key. You know? So that's why if we go with this one, so we have company, the name, NAICS code, telephone number, address, and assets. So the company has a unique name and a unique NAICS code and a unique telephone number. I think it should be not a unique NAICS code. So it's a telephone number. I'm sorry if you have, but anyway, so this I need to revise this question. So this code is not unique. This code actually is used to representing the type of business a company is in. So it's possible several companies may have the same type of business, right? So NAICS code is not unique. But anyway, the name and telephone number should be unique for each company. So then what can be the super key? So before we determine the super key, we must first identify the key. Your super key must contain a key, okay? So in this case, this company name is a key and telephone number is a key. So still we have two keys in this one, okay? So then once we have these two keys, now we know what is super key. So name is a super key. Okay, so a super key must contain a key, okay? So it satisfies that condition. Then name and telephone number is also a super key. You understand? So super key does not need to be minimal. So a super key can contain redundant attributes. You understand me? So in this case, name and telephone number is a super key. Address, assets is not, because it does not contain a key. Name, address, yes, because name is a key. Okay, so name, address is super key. Okay, then the telephone number, yes, it's a key A key is also a super key, but a super key may not be a key if a super key contains some redundant attributes, okay? Then let's call this now. So that's why we have 4. Okay, so you can hear that a key is always a super key. Okay, so that's why name and telephone number is also considered the key, but also we can consider them as super key. Then the name telephone number is a super key because it contains a key. Actually, it contains 2 keys. And the name address is a super key. That's contains a key. Okay. So these are 2 I want to discuss. Then regarding to SQL query, I think if you don't know how to write SQL query, then don't be panic. So I think we're going to discuss SQL query depending on if, for example, if the whole class are pretty confident about SQL programming, if only 1 or 2 students, I may encourage you to read the slides beforehand. But we're still going to go over the SQL program. Okay, so that's pretty much what my plan. So the remaining SQL query I will not cover in today's lessons because we're going to go over those programming in the maybe second part of this semester. Any questions? No? Okay, any questions from online student? Let me see. So I think we have pretty good attendance, but okay, so any questions from online student? Okay, so if you don't have any questions, we are done for today. Do you guys have a piece of paper? I want to write down your name. Thank you, Susan. Any questions?
Should I write the names?
Yeah, just write your name. Yeah, just stop. Yeah. Okay, if you do not have any questions, then we are done for today.